see what would happen if this 40 Newton per unit square, which was tensile, was not tensile, it was compressive. What would happen? How would the diagram change? So x-axis, it is tensile. So I actually put this on the same place. But earlier it was tensile, so I put it here. So it should not be here, it should be exactly on the opposite side. So I'll remove this, can erase all this, can erase all this. I'm trying to tweak all this because I want to show you how this makes a change. Okay. So this is 100 Newton per unit square. This side is 10, 20, 30, 40. So this is 40 Newton per unit square, which is actually sigma y. Okay. Now which is the midpoint of these two? Divided by 30. Okay. So 70 from this side is actually 30. So 10, 20, 30. So I'm here. So at 30, you should draw a circle. I mean, from here you should draw a circle. Now you'll see that the circle is quite larger, which means that suddenly because of this sigma y direction has changed, the circle has become bigger, which means that suddenly the shear stresses have increased. But the normal stresses have not increased. The value of normal stress has changed from plus to minus here, but suddenly the shear stresses have changed. Okay. Now for this diagram, can you tell me, suppose if I want the stress again at 15 degree or maybe 30 degree, I want this at an angle of 30 degree now, at an angle of 30 degree, then what I should do? So then I should select this point and then draw a line at an angle of 60 degree. Then where this point meets the circle, that point will give you what is the shear stress at that point. The shear stress has to be measured how? How it has to be measured? By drawing a parallel line. So you can measure the shear stress at this point by drawing a horizontal line. You can measure the normal stress. So shear stress can be measured like this, normal stress can be measured like this. Guys, will this equation still hold good? Yes, it holds good because sigma x plus sigma y. So this is, it was minus, no? So sigma x was how much? 100. Sigma y is how much? It is minus 40 divided by 2. So how much is it? 30. So you got this center point as 30. So that is the distance. That is, right now this value is this. And what is the radius? This value. So radius is how much? So 100 minus 40. So that is minus and minus becomes 40. 140 divided by 2. That becomes 70. So this 70 is the radius. Okay. And this cos of this 70, the cos of this radius will give you this distance. So the sum of this distance will give you sigma. So the same equation will definitely hold good. And also this equation also holds good because this sigma x minus sigma y by 2 gives you the radius. Sine component of this radius will give you tau. Cos component of the radius will give you this part, which added to this part will give you normal stress. So like this, you can definitely solve any numericals where sigma x and sigma y values may change. Even sometimes these values here also may be different. Both are negative. Then how would you solve it? Exactly the negative direction. The same way. Okay? So usually in most of the problems they give one as positive, and most of the problems that you see are like that. So you can also practice numericals where both the forces are negative and so on, and check whether this equation still hold good. Okay? And now I will have some special cases here. This is okay? Are you done with this? Okay. Now coming to the special cases. Guys, in this, let us say that instead of 100, this is 1 Newton per m square. This is also 1 Newton per m square. 1 Newton per m square is how much? So, okay, sorry, I think instead of 1 Newton, 100 only. I'll take it as 100. 100 Newton per m square, 100 Newton per m square. Both are like this. Then what would happen? Then how do you draw this diagram? Both are 100. Both are tensile. Both are tensile. Both are tensile like this. Then how do you draw the diagram? So sigma x also at 100. Sigma y is also at 100. Where will you draw the circle? What will be the radius of the circle? 0. So that means the circle is itself in the dot. The circle has no radius. It is at this point. So that means when you got equal normal stresses acting on a material in the same direction, it will have 0 shear stresses. Shear means what? Basically, a body changing shape like this, a body which is like this, changing shape like this, where an angle changes like this, is called a shear. But when a body is expanded in the same direction by, when a small cube like this becomes a larger cube like this, then any line which was drawn here will be the same line. Suppose if this body which was like this is applied with the 100 Newton and then applied with 100 Newton like this, then what will happen? The body which was like this, now which was a square earlier, will become a rectangle like this. Earlier it was a square, now it becomes a rectangle. So now if you consider this edge, suppose if you consider from one edge, and if you have actually drawn a line, I think it is very difficult to say like this. So then basically I can say that a line which was actually drawn like this, it's very difficult to say whether it is inclined or not, but I can say that the shape has changed. Whenever there is a change in shape, earlier a square was remaining as a square, no change in shape, no shear strain. But a square has now become a rectangle. So that means that there is a change in shape. So that means there is shear strain. So whenever you have equal normal stresses on both the sides, then you can't draw this Mohr circle because the Mohr circle is a dot. Okay?